Welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic today chosen is from Chapter 6 System of Particles and Rotational Motion. Today is not problem solving session, it is a questionnaire session. That is 7 questions will be floated and next session we will solve the solution of these questions. Let's move to first question. 3 identical spheres, each of mass capital M, are placed at the corners of a right angle triangle with the mutually perpendicular sides equal to 2 meter as shown in the figure. Taking the point of intersection of the two mutually perpendicular sides as the origin, find the position vector of center of mass. Option A 2 I cap plus j cap. B option I cap plus j cap. C option 2 by 3 I cap plus j cap. D option 4 by 3 I cap plus j cap. By knowing the formula for center of mass, you are able to find a solution for these questions. Let's move to question number 2. Two particles of mass 5 kg and 10 kg are attached to the two ends of a rigid rod of length 1 meter with negligible mass. The center of mass of the system from the 5 kg mass particle is nearly at a distance of dash. Option A 50 centimeter, B option 67 centimeter, C option 80 centimeter, last option 33 centimeter. By knowing the formula for center of mass with respect to that masses and distance, you are able to find the solution for these questions. Let's move to question number 3. The moment of the force F equal to 4 I cap plus 5 j cap minus 6 k cap at 2, 0, minus 3 about the point 2, minus 2, minus 2 is given by dash. Option A minus 7 I cap minus 8 j cap minus 4 k cap. B option minus 4 I cap minus j cap minus 8 k cap. C option minus 8 I cap minus 4 j cap minus 7 k cap. D option minus 7 I cap minus 4 j cap minus 8 k cap. Here I, j, k are the position vector along x, y and z axis. So by knowing the formula for moment of force in terms of F and the distance, you are able to find a solution for this question. Let's move to question number 4. A rope is wound around a hollow cylinder of mass 3 kg and radius 40 centimeter. What is the angular acceleration of the cylinder if the rope is pulled with a force of 30 Newton? Option A 25 meter per second square. B option 0.25 radian per second square. C option 25 radian per second square. D option 5 meter per second square. By knowing the idea about the rotational motion, that is angular motion, you are able to find the solution for this question. Let's move to question number 5. The moment of inertia of a thin uniform rod of mass capital M and length capital L about an axis passing through its midpoint and perpendicular to its length is L0. Its moment of inertia about an axis passing through one of its ends and perpendicular to its length is dash. A I naught plus M L square by 4. B I naught plus 2 M L square. C I naught plus M L square. D I naught plus M L square by 2. Let's move to question number 6. The ratio of the radii of gyration of a circular disc to that of a circular ring, each of same mass and radius around the respective axis is dash. A option root 3 is to root 2. B option 1 is to root 2. C option root 2 is to 1. D option root 2 is to root 3. That is, you want to find the ratio of the radii of gyration. So by knowing the formula of radii of gyration with respect to that masses and radius, you are able to find a solution for this question. Let's move to last question, 7th question. If a sphere is rolling, the ratio of translation energy to total kinetic energy is given by dash. A option 7 is to 10. B option 2 is to 5. C option 10 is to 7. Last option 5 is to 7. By knowing the formula for translation energy and total kinetic energy, you are able to solve these problems. So in next session, we will find a solution for this problem. Before that, you try to work out this problem. Thank you.